Thank you, Paul, and thank you, Jose, for the introduction and of the overview of the market. It relates directly to what I'm going to talk about in the next few minutes.
Oh, good.
And this is our industry, how the SATCOM industry needs to deal with this changing era, what we call an elastic era in Gilat. So I will try to cover it from several aspects. First of all, of course, the challenges that the new software-defined satellites are bringing, what kind of solution we think should be used over those satellites, and we'll touch another subject which is very critical to SATCOM those days, which is cybersecurity and how we see it and how we think it should be dealt looking forward. So I will start with direct connection to what Jose talked about, and this is the changing market. Our satellite industry is going through a very, very big change and revolution in almost every aspect of the satellite industry as we know it. The designing of satellite, the production of satellite, launching of satellites, how they play in orbit, what kind of capability they have, and at the end of the day, all of this translates to what kind of services the next couple of years will offer over satellite. And the increased capacity that Jose talked about and the non-geo orbits that we are seeing multiple kind of companies doing multiple deployments is affecting all of those things. And this change is actually is not just about NGSO. We all talk all the time about LEO, Starlink, OneWeb, Amazon, and others. We talk about SES, mPOWER, but at the end, this is also goes into GEO. At the end of the day, the change and the increasing capacity and the change in the technology is also slipping into the GEO satellites, and we are starting to see new type of satellites, software-defined satellites, very high throughput satellites that are coming. Some of them are already out there. Some of them will be out there next year, like Intelsat, IS-40E satellite, for example, and others. And all of that means that there is going to be a lot more capacity, a lot more options for satellites and for services over satellite. So this change, and we talk a lot about NGSO, but I want to touch also about GEO. This change in GEO, the move from HTS to VHTS satellite, has a huge impact on this segment as well. The throughput is increasing, the capacity is increasing, but also the number of beam is increasing. We will start to see, we already see it, but I think next year and the year after, we will start to see new band introduced into our environment, the QV. For the gateway beam at least, we will start to see it there. The transponder become much wider with a lot more capabilities, many more gateways. The industry is moving into an environment of hundreds of gateways can be deployed over a single constellation or a satellite, and the satellite itself becoming much more complex. A software-defined satellite with a very, very flexible architecture that can change the number of beam, the coverage of the beam, the power over the beam, and also technologies inside of it, like beam hopping and others. All of that is making a change also in the technology level of the world that we are living here. And it's not just in NGSO. NGSO add another level of complexity on top of all of that, that the satellites also move. And it's changed places all the time, or the satellite that covers us in every minute is a different satellite, and the systems on the ground needs to cope with that as well. And this is where we want to see that there is a change. There is a change on the satellite. A software-defined satellite means that the ground segment needs to adjust to that as well. A satellite that can change the shape of the beam, the structure of the beam, the power of the beam, the location of the beam dynamically, maybe even several times an hour, requires a ground segment that can cope with that changes. We say for many years that the ground segment needs to be a software-defined, but it's not just being a software-defined, it's also be able to match and cope with the satellite that is a software-defined. Sorry. It means that the ground segment needs to cope with that, and one of the places to cope with that is a cloud-based ecosystem, where you move into the cloud, your baseband, your data center, your management system, in order to be able to cover a lot more ground, because if you have hundreds of gateways and tens of data centers, you cannot deal with it with the whole way of having many hardware deployed, unique hardware deployed all over the world. You need to move to something more common, like a cloud. And the ecosystem of such a system includes the software-defined satellite, the managers of the satellite, and managing the ground segment in a very flexible way. This is also leads to the density. Bigger satellite that has much more throughput requires you to put more equipment on the ground. But if you move into cloud, this is where you can do much more flexibility and give the density that is needed in a very simple way, in a way that will less impact the operators. Most of the operators are not managing only satellites, and they are used to. The last few years in other technologies already moved into the cloud. 5G is a great example. Satellite cannot be different. It needs to act in the same way. It means that the entire infrastructure of a satellite network, which is consists of the satellites in the skies, but also the ground segment, must be elastic. And this is where the name of the Elastix Era comes. And we need to be flexible. The number of satellites can change. The shape of the beams that they're creating can change. The number of the beams per satellite can change. The ground segment need to cope with that. It can be smaller at night, bigger at the day. You need to deploy maybe more gateways in some places, less gateways in another places. Data center need to be flexible. You have more traffic in certain time of the day, less traffic in others, and you need the system to be flexible. For example, in the morning, there is more flight on the east coast of the US. In 3 hours later, there is more flight in the west coast of the US. You need to be able to shift your capabilities, your capacity, your data processing from the east to the west as time changes. The network must be flexible to allow that in a very, very simple way that is simple for the operators, simple for the users, and simple for the service providers. And this is where the Elastix Era comes. Everything needs to work together, the satellite, the ground segment, and to be flexible and elastic to cover all those changes. Much more satellite, much more capacity, much more service required. SkyEdge IV, for example, Gilat's latest product that we released earlier this year, is aimed exactly to that. The whole philosophy of SkyEdge IV is to be an elastic, open platform that can deal with this evolution. In the next years, we will see the shift from the traditional satellite to a software-defined satellite, the transition from a fixed network to a flexible network. All of that needs a system that can cope with that can be more efficient, more dense, virtualized. Virtualization is a critical path for that, able to cope with various type of throughput. It can be from very low bitrate for IoT to very, very high bitrate for cruise ships and airplanes and other kind of backhauling deployments that requires a gigabit and above. All of that needs to be covered under the same system. You don't want to deploy multiple systems. You want to be flexible with the bands that you are using, efficiency, of course, have APIs that can interact with orchestrator and SDNs and off-the-shelf solutions like in other technologies, 5G, MEF, MEF kind of solutions. You need your system to have all these APIs for that. Resource managers that manages the satellite must interact with the ground segment. So you need a system like SkyEdge IV that has this API for those kind of integrations that will allow the operator to create a very, very efficient network that can deal with any kind of demand from the customers, any kind of services that it will require. We will touch some of the application and solution in a few minutes. On top of that, you need to maintain your current deployments. So backward compatibility of the next generation system is critical. Customers are deploying networks, deploying solutions today, and they don't want to change it in a year, 2 or 4. So you need to have some kind of a forward compatibility to existing modems and deployment into the next generation solution. And this is part of the things that we are bringing in SkyEdge IV. So some of the solutions that are relevant for this new era, for new type of satellite, first of all, is the traditional 5G deployment. But the 5G deployments today also needs to deal with what we call the private networks. Deployments that are not just to extend the cellular network coverage, but also to provide a network in an isolated environment like campus, like military, like government, facilities that want to have their own private network from one end, but also have the ability when needed to connect to other networks. 5G backhauling needs to evolve into that environment. First of all, to support 5G, but second of all, to allow this private network environment when you can deploy that for all kinds of solutions. The other type of solution that we are seeing increasing more and more with these new satellites and new capacity available is disaster recovery and fast responses. Sadly, there are a lot of events around the world that requires first responders to come and deploy a network when traditional terrestrial infrastructures are down because of floods, earthquakes, and others. We see it in the news all the time. And this is where satellites come into play, the ability to do a fast deployment, the ability to get a fast deployment of a solution that can help the first responder to get into the area, to give a coverage, to give a performances that first of all will go to the emergency units, but second of all also to the people itself, to be connected and to connect with each other and to talk to each other when it's needed during a crisis. This is the main application for the new age of satellites. It's already available today in many places. We think we will see more and more on that. Military and government will take leverage of this new era of satellites because more throughput will come, it will be more available, lower latency, all kind of solution that will help the military and government to expand their coverage, moving from the traditional MSS and low bitrate kind of application to having a commander on the field talking with a video HD with the headquarters and giving the instruction that he needs, or other kind of scenarios like in UAVs or ships or other things. So this new era will also affect, of course, the defense application that we are familiar with. First of all, from the scalability point of view, having much more capacity available will bring it to much more places in the defense environment. The performance required will be much higher than today, and satellites and the modems out there will need to cover for that. We are talking about new age when you will need 1 gig to a terminal, and this is something that we're already seeing as a demand. And of course, security, and I will touch that in a few slides, talking a little bit about security, which become more and more critical, not just in the defense world, but also in commercial world. As I said, all of that needs to connect to a traditional terrestrial networks that already use 5G interfaces, MEF interfaces. There is all kind of protocols out there and kind of solution, and the satellite network cannot remain as an isolated world that only talks with itself. The satellite network must be connected to those networks as well, speak the same language, at least in the level of the service, at least in the level of the controlling of the network. Later on, there are all kind of initiatives like the 3GPP 5G NTN initiative that might affect that also on the access level, but at least in the level of connecting the network, we must talk in the same language. So having a Presto, for example, as an interface from the satellite management system, from the NMS, into traditional 5G and MEF networks is a crucial element in order to make the satellite network part of any other communication network out there, and not a unique, isolated solution that needs a special treatment. And as an example, high throughput application is cruise ships, and we are seeing more and more demand in this area, becoming a standard. You don't want to go back to the days of having multiple modems just in order to get to the 200, 300, 400, 500 megabits that the cruise ship needs. Today, you want to put a single modem that can do 1.5 gigabit to a ship and give the service that a cruise ship requires with all the hundreds and thousands of people on board this ship. The need to connect for people today is becoming more and more evident. Everybody is on the social media. Everybody wants to post their videos and pictures, even if they are in the middle of the sea. And this calls for a different level of service. Having high throughput satellites with a software-defined capability that allows you to do a tracking beam on top of a specific cruise ship requires also a ground segment with a modem that can deal with that can give the performances, that can integrate with multiple antennas on top of the cruise ship for having a coverage almost 100% of the time. To be able to connect to all kinds of devices that are on board the ship, you need to be a layer 2. So this change, we will see more and more of that. Adding to that, the need for edge computing. You don't want to take all your data into the cloud. There are a lot of things that you need to do on the edge in order to be more efficient. And edge computing with a solution on a cruise ship It's something that we are seeing as a growing demand, and this new era will bring more and more in that. Not just a cruise ship. I pick one example here. You can think about agriculture. You can think about other kind of scenarios that requires more throughput, edge computing, and a new kind of solution that will connect everybody everywhere. All this is fine, but what we are seeing lately that this is not enough. The last year, I think, in the satellite industry, make it very, very clear. SATCOM in general, satellite communication, is more vulnerable to cyber attacks. The idea that you transmit everything over the open air through a satellite makes it more vulnerable and more sensitive to attack. And cybersecurity today is a must in SATCOM. If in the last years, people thought about it more as a military and government kind of solution, we see today, especially in this last year, I won't count all the issues that everybody's aware to that, but we see it also for commercial communication. The need for cybersecurity is critical. And cybersecurity is not just one thing to do and that's it. It builds over layers. The basic layers, of course, is to do encryption for the links of the data and the management, to do segregation of plans, divide between your data control and management, to, of course, run with the latest firmware and software in order to get all the patches that are relevant for security. This is basic. On top of that, you need to go into a new type of model. A zero trust security model means that we don't trust anyone. The idea that if I put my hub and equipment in a room that has a lock on the room is enough, this is not true anymore. People can hack into this room in various ways. You need to make sure that every device on your network is protected. And if the network was breached to one device, you won't be able to get into another device. If it breached to the management, you won't be able to get into the control. This is called a zero trust security, and this is where the next level of cybersecurity needs to go. Everything needs to be encrypted, not just the traffic over the air. Also the messages inside your system between the components need to be encrypted. And all of that needs to go into logs, into anomaly detection tools, in order to be able to detect very fast any problem, any change in the behavior of the network, in order to identify that something happened. All of this is technical, it's just to do features, but this is not enough. At the end of the day, the most important thing in cybersecurity is to manage the vulnerabilities that you have. To always have a system, people that are looking into your system and making sure that if they found something, it's documented and it's being fixed. In order to be ahead of the attackers, of the hackers, you must check your system all the time. You must manage your risk. You must do by yourself vulnerability assessments constantly on your system. Don't trust your customers. Don't trust others. Do it yourself in order to make sure that your system is protected, and try to identify critical vulnerabilities before others find it. And this is the way to stay on top and to have your system secured and improved for your customers. Of course, customers are doing it as well, and we always talk with them and we listen to them, but we need also as vendors to do it by ourselves, because this is the only way to stay ahead of the others. Try to hack your own system. If you succeed, others will succeed as well. But if you succeeded first, you can close that door. You can patch that and make sure that others won't be able to use that. Thank you.
Okay, thank you very much, Gil. Jose?
Yes, thank you so much, Gil. Very interesting presentation. It seems like there's a lot of complexity that's needed going forward. Security is the last thing you mentioned, but virtualization, plug and play, off the shelf. And then you've got multi-orbits, you've got many different segments. And then you need backwards compatibility as well, because there's a lot of installed base. And Gilat seems to have the solution for that. So congratulations. But in terms of price, in order to account for all these bells and whistles, all the applications, all the complexity that gets into the application layer and others, is that going to raise price? I think one of the issues that we have in the satellite industry is the economies of scale is not quite there yet to reach the mass markets. Your comments, please, Gil?
So yes, you are right. And price today is even more challenging than before with all the supply chain issue that is still ahead of us. It's not over yet. And price is always an issue, even when there is no supply chain issues. But those are exactly the thing that you mentioned, and I mentioned in the presentation as well, is part of the way to deal with the price. For example, when you move into cloud, when you make your system virtualized system, it means that for the service operator, it's much easier to deploy your solution. Some of them already have a cloud solution, either public cloud or a private cloud or some kind of hybrid solution. And this is one way to manage the price of a network. You don't need to deploy the hardware yourself in your gateways. You can use cloud facilities for that can help you to reduce the cost of that and the cost of the service as well as goes for that. Terminals are bringing much more throughput and capabilities, but the terminal's prices typically stays the same more or less. So you are getting more throughput for the same price. So maybe the price didn't drop, but the price per megabit, per gigahertz dropped because you are paying same price for much more throughput. And this is something that we are also seeing in the market. Combine that with what you presented of having much more capacity, it means that at the end of the day, the price of a service will go down. Equipment will do more, will be virtualized in cloud, which will reduce the cost of maintaining a network. On top of that, much more bandwidth will mean drop of the price of the bandwidth. Much more application that will use that, because at the end of the day, like I mentioned, same kind of solution can deal with low bitrate IoT from one hand, and cruise ships with high throughput on the other end, means that you have more application that you can sell, more services that satellite operator can sell, and this is another way to increase their revenues, to increase their share. So overall, I think those changes will also lead at the end of the day to a price reduction, at least on the level of the megahertz or the megabits per second, per month, that will change because of all of that, because your overall OPEX cost will go down.
Excellent. Great. Thank you. So we'll discuss that more later on, but I guess what I'm hearing is that complexity is good. It's really actually addressing the price issue. It's really about total cost of ownership, not just one part of the segment. So thank you, Gil. We'll come back to you with, we'll see you back in the panel a little bit later. Back to you, Paul.
Thank you.
Okay, yeah, thanks, Gil. Interesting that you put such an emphasis there on security. Is it the cloud provider that would be responsible ultimately for that security, or are they just going to enhance the security that's already in place?
It's everyone. Cloud provider already today have security means, and they will, of course, will improve that. But also equipment vendor or solution vendors like Gilat improve their security and their means of security, and the service operator, the satellite operator, improves their security. It's all of us. Everyone needs to do their part. Like I said, zero trust model. Don't trust anyone. Make sure that your part is secured and don't trust the others. And this is the way that all of us will be better, and the solution will be much better, and the security will increase. So it's not just one that needs to do the work, everyone.
Okay, thanks, Gil. Look forward to bringing you back for the panel discussion a little bit later.